so like we said, everything so far that we've talked about that we're launching or throwing or whatever, horizontal. So now we're going to start launching things at angles. Okay, so let's draw a couple pictures just to get started, and then we'll do an example problem down here and talk about some of the mistakes that are made in these problems. Okay, so first picture, let's just draw some kind of surface here, and we're going to have a golf ball, and let's say it's hit like that. Okay. Alright, so I put on this one easy golf and difficult golf. Reason why is because here we have no elevation change. Okay, so that's meant to be a flat surface there, but this table's really bumpy, so I should have used a ruler. Don't make excuses? Okay. So basically I should say I'm just horrible at drawing lines. Is that better for you guys? Okay, so draw an arrow something like that.
I have a question.
Okay, question.
Would like the elevation change and like the sign?
Yeah, elevation, yeah, we'll deal with that here in a second. So the dotted line, that's the path that the golf ball is going to take. This line right here, that's a velocity vector. Okay, how fast are golf balls hit? What'd you guess? 115 miles per hour. Okay, so let's call it, let's say 60 meters per second. All right, as an estimate. Okay, so this that I'm drawing right here represents the initial total velocity of the projectile. All right, we're going to call that VT, V total. And you learned in vector boot camp that we can break that into a horizontal and a vertical velocity, like that. And we call this Vx and we call this Vy. Okay, so down here, deadly mistakes. I'm going to say this to start. We will never plug the V total into an equation. Can't do that. Okay, who knows why? Why can't we do that?
Isn't it just because like you can't find anything
Okay, well, let's look at this. Don't we do these horizontal, vertical tables?
well,
Isn't it both? That's the answer. Okay, this is horizontal and vertical, right? It's horizontal this much and vertical that much. Okay, so we can't put 60 on this table. We have to break it apart into its x and its y. So vector boot camp shows you, I'm going to shorten it a little bit, how to get this. We're going to do 60 times the cosine of whatever angle that is. So I'm going to say that this angle, and I'm just making this problem up on the spot, but I'm going to say this angle's 75 degrees. 60 cos 75. Okay, that's my x component. My y component is 60 sine 75. All right, so let's calculate those out real quick. All right, we always want to ask ourselves if our answers make sense in case we're in radians or something like that. That's another, let's add that to the list. Yep, calc needs to be in degrees. So before a quiz or a test or something on this, if you guys go, hey, everybody change to degrees, all right, because in math you used radians for something, your class will appreciate you for that. So those kind of warnings are okay as long as we haven't started the quiz. All right, so our Vx, 57.9, so I'm just going to round it to 58. That pen is gone. And that's meters per second. And then, oh wait, I messed that up, didn't I? Okay, this is 15.5 meters per second. Okay, and I guess to be consistent, we'll say that this is 58.0. All right, now from here, this is pretty much exactly like any problem we've already done. We have now broke this into horizontal and vertical. Okay, so we can solve for unknown quantities that we want. All right, so let's make another one of these charts right here. And this isn't an actual problem. We're not actually asked to find anything here. But let's classify what we know. Okay, vertically, we are going to call the V initial in the y direction 58.0. Okay, now as the ball goes up, okay, tell me about its vertical velocity right here. 0. I'm going to say Vy equals 0 right here. Okay, and then as it hits, it's also going to have a vertical velocity Vy. And this is a level playing field, easy golf. Okay, anybody have any idea what that would be? Okay, now remember, we want to say 0, right? Because the ball's hit, it's landed, it's stopped, right? But we always in projectile problems are talking right before it hits. Okay, so let's say I take this football and I throw it up at 10 meters per second. What's it hit my hand with? Close. Negative 10 meters per second, right? Okay, now the golf ball, it's going up at 58. So what is it going to come down at? Negative 58. So this is negative 58 meters per second. Okay, so depending on the problem, couldn't we say that this or this is a V final for the y direction? If the problem's asking us something about the top, we can say V final for y is 0. If it's asking us where it hits, we can say V final is negative 58. Okay, questions about that? We'll do some examples too. Okay, but this is what we just did. That's really all the new stuff that I'm teaching you. Everything else you already know. Okay, Hannah? Okay, now delta y, we aren't given any distance information or anything like that in this. So we're not actually going to do the problem. We're just going to kind of put some of the numbers that we know here. Okay, so let's add some things. The acceleration's still negative 9.8. And over here, the horizontal is 15.5. Okay, now 15.5 applies where? It's the horizontal. The whole time, that's exactly right. The horizontal velocity does not change. Okay, just like we've been doing the whole time. All right. Okay, let's look at this one. Projectile with an elevation change. So let's say we have a cliff now. And anybody ever owned a potato gun? So fun, right? Yeah, just a little one, or yeah, potato guns, good time. So let's say we're gonna launch a potato gun like that. And we could draw the path. Okay, something like that's gonna happen. And I could give you a number here and here. Okay, and we could talk about breaking this into its components. Okay, so here's my X. Here's my V initial in the Y direction. All of that applies over here. Okay, but let's talk about when it hits. Okay, then it becomes different. How? Okay, it still will be negative. So the Y velocity will be negative when it hits. But here, weren't those velocities the same?
Yeah.
Just opposite sign?
Even absolute value would be greater, I guess. It's like it's still
Okay.
less than, but it's more less than.
Yes, it is going to hit with a higher speed, vertically. Okay, so let's look at this. If I draw this horizontal line across here, isn't that, and I take this away, isn't that the same as this problem right here? Okay, now let's go to this. We are now gaining vertical speed in the negative direction as we go down here. Okay, so we're going to have to know things like maybe delta y. We're going to have to know how high the cliff is. We might have to know something about time. All right, all kinds of different things, okay? Difficult golf or potato gun launching. So these are the two types of problems we're going to deal with. Well, there might be one more. Okay, I'll show you guys this. What if we take the potato gun and launch it downward at an angle? Here I'm starting out with a positive VIY. Okay, then my triangle is going to be pointing down, and I'm going to start out with a negative VIY. So the big deal here, guys, is signs. As long as you watch your signs and you do your trig right, you're going to be able to fill in these tables and do okay. All right, Jack, you got a question? If it's pointing downward, yeah. Yeah, and depending on which angle's given to, and we'll do some of that, so you have an example. All right, so here's some other deadly projectile mistakes. Saying V final in the Y direction equals 0. Okay, unless of course we're talking about the top up here, because V final up here would be 0. But people love to say, oh my gosh, this thing hit the ground, it stopped, V final in the Y direction is 0. So really we're talking about right before it hits. All right, last thing. Alright, not realizing that the acceleration is still just negative 9.8. Okay, any questions overall before we start working problem or two? Football is kicked at an angle of 37 degrees with a velocity of 20 meters per second. We want to calculate maximum height, time of travel, the total time of travel, and then some more stuff on the back. Okay, so let's draw a really simple picture over here. Football's going to do that. And is this easy projectile or difficult projectile? Easy, because it's a level playing field, right? Football fields don't have like a big cliff right here that you then have to navigate. That'd be cool. Let's make it interesting. Let's put some weird obstacles on football fields. Yeah, we could put like a swamp in there and some other stuff. That would be really cool. It's not going to happen overnight, folks. Okay, then this is a 37-degree angle, which I drew way too big. And this is our 20 meters per second. It is giving you the v total, which is kind of normal. Usually we're given the total velocity and not one of the components. Okay, by the way, what do I mean by components? We haven't used that word a lot. X and Y, yep, the components of the vector. Okay, so let's do our little chart. And let's do the easy stuff first. Acceleration equals negative 9.8. Anything else we know? Okay, what point are we being asked about? Okay, maximum height. So what do we know about V final? V final in the y direction equals 0. And the problem is never going to come out and tell you that. You are going to have to think about the physics and figure that out. Alright, now V initial in the y direction is equal to, let's figure it out. So here's the initial y, here's the initial x, VIY equals 20 cos 37. Okay, always make sure you put the angle after the, yeah, did I do that again? I'm doing it just so that you guys think about it and catch me. Okay, 20 sine 37. Horizontal 20 cos 37. Okay, so Javen, read me off what 20 sine 37 says.
There's 12.03.
12.03, you guys agree? Okay, I'll keep 3 sig figs. Alright, what about this one? Callie, what'd you get for this one? 15.9 what? 0.97? Okay, I'm going to make it 16.0. Now on UT homework, you might not want to round quite that much on your intermediate steps because that carries through. But for this, it's fine. Okay, V initial, 12.0 meters per second. Now, is that positive or negative? It is positive, okay? Because we're not launching something down here. My horizontal velocity, Vx, equals 16. And here's what we want to find. We would like to find delta y. And there's a couple ways to do it. Okay. Do we have enough information over here to solve for delta y? No, this is horizontal anyway. We wouldn't use that. Okay, so vertically, what are we missing here? We're missing time. So let's use our time-independent equation, which is Vf squared equals Vi squared plus 2a, and we're going to say delta y. Okay, Jack?
Can you just immediately switch delta x to delta y like that?
Yes, because I'm going to use little g right here. So
Well,
since...
if it was like delta x equals blank plus blank, could you also do delta y equals positive? If it was like switch.
So the reason why I don't put delta x here anymore is because horizontally there is no acceleration. So I'm not... Is that what you're asking?
So I guess that equation originally has delta x in it.
Yep.
So and then you put delta y, so I'm saying there are other different ways to do that.
Yes, you can. Yeah, you can do that. Okay, let's rearrange it. So I'm going to have VF squared minus VI squared equals 2A delta Y. And now I just simply have to divide by 2A. Alright, now plugging in some numbers. My V final is 0. That goes away. Okay, so minus my V initial, so that's 12 squared. Two times negative 9.8. Okay, and oops, sorry, we don't square that minus sign. We square this, then we are subtracting it. Okay, so we don't do that. And that means both of these are going to cancel. Okay, and we want our delta y to come out what sign anyway? It's got to come out positive because we're assuming that this is 0 down here. Okay, so 12 squared is 144. Divided by 19.6, which is 2 9.8s. So we get 7.34, or 7.35 if we keep the 3 sig figs. Alright, and that is meters. Okay, what do you guys think? Any questions? None at all? I feel like there should be some. Okay. Alright, so the next pieces here, how about this? I'll give you guys the answers. This one is time equals 2.45 seconds. How far away it hits the ground, that is 39.2. And velocity vector at the maximum height, okay, you have to draw it. Acceleration vector at the maximum height, you got to draw it. Alright, so work on those and then we'll go over them when we're done.